dear students. Now I am starting my part 3 in probability. I will take a sum now. Two numbers are selected at random from 20 consecutive natural numbers. Find the probability that the sum of the two numbers is 1, even, 2, odd. Suppose if we take 20 natural numbers, consecutive natural numbers, అంటే వరుసగా ఉన్న 20 నెంబర్లు తీసుకుంటే ఫస్ట్ ఒకటి ఆడ్ ఒకటి ఈవెన్ అట్లా మీకు 20 నెంబర్స్ లో 10 ఆడ్ నెంబర్స్ ఉంటాయి, 10 ఈవెన్ నెంబర్స్ ఉంటాయి. నెంబర్ ఆఫ్ ఆడ్ నెంబర్స్, ఆడ్ డిజిట్స్ అదర్వైజ్ ఆడ్ నెంబర్స్ ఈజ్ ఈక్వల్ టు 10. నెంబర్ ఆఫ్ even numbers is equal to 10. So here the sum, if you take two numbers, the sum of those two numbers must be even. For that purpose, the two numbers must be either even or odd. Both must be odd or both must be even. So let us consider the event as E. Let E is equal to sum of the two numbers selected is equal to even number is equal to even number. For that, both numbers should be either odd or even. How many ways we can select two numbers from 20 numbers? It is 20 C2. That is n of s. Total number of selections of two numbers from 20 is equal to 20 C2, which is equal to 20 into 19 by 1 into 2, that is 190. Next, n of E. You have to select two numbers from 10 odd numbers or two numbers from 10 even numbers. Now that is 10C2 plus 10C2. 10C2 plus 10C2, that is 10C2 means 10 into 9 by 1 into 2 plus 10 into 9 by 1 into 2. So that is 90 by 2 means 45 plus 45. So altogether 90. So you can select two numbers whose sum is even in 90 ways. So what is the probability for the sum of the two numbers is even? Therefore, P of E is equal to n of E by n of S. That is 90 by 190, which is equal to 9 by 90. So 9 by 19 is the probability for the sum of those two numbers selected is even. Now if that is sum is not even, it should be odd. So 1 minus this, that is complementary event. So second, probability for the sum is odd is equal to 1 minus P of E equal to 1 minus 9 by 19, which is equal to 10 by 90. So, these are the probabilities for the sum to be even, that is for the sum to be odd. Now, I will explain one more problem. Now, there are 3 horses are there in a race and their probabilities are given like this. A, B, C are 3 horses in a race and their probabilities are as follows. Probabilities are as follows. One is the probability of A to win the race is twice that of B. Probability of A to win the race is twice the probability of B, and that of B is twice the probability of C. What are the probabilities of A, B, C to win the race? What are the probabilities for A, B, C to win the race? Here, probability of A is twice the probability of B and probability of B is twice the probability of C. Then what are their individual probabilities? Now which is the least? C, probability of C is the least. So let us take that probability of C as K, some constant K. Let P of C is equal to K. Because the probability of B is twice the probability of C, it should be 2K. P of B is equal to 2 times probability of C, that is equal to 2K. Because P of C is K. Now what about P of A? So that is twice the probability of B. P of A probability is twice the probability of B. So that is 2 into 2K. That is 4K. Because no other horses are there in that race, these 3 are adjust events. So the sum of these 3 probabilities must be 1, because only one of them will win definitely. So P of A plus P of B plus P of C must be equal to 1. We know that P of A plus P of B plus P of C is equal to 1. What is P of A? 4K plus P of B 2K plus P of C K is equal to 1. So it is 7K is equal to 1. Implies K is equal to 1 by 7. Now let us write the probabilities separately. What is P of A? P of A is equal to 4K. Equal to 4 into 1 by 7 equal to 4 by 7. P of B is equal to 2K. 2 into 1 by 7 equal to 2 by 7. P of C is K, that is 1 by 7. So these are the individual probabilities. If you add these 3, you will get 1. Next, one more question. The probability Now one more question. The probability that a boy A will get a scholarship is 0.9, and for B it is 0.8, and for B it is 0.8. What is the probability that at least one of them will get scholarship? Probability for A to get the scholarship is 0.9, and for B the probability is 0.8. So what is the probability that at least one of them to get the scholarship? Now here P of A, probability for A to get scholarship is equal to 0.9. P of B, probability for B to get scholarship is equal to 0.8. Now, what is the probability for A not to get the scholarship? That is 1 minus P of A. P of A bar is equal to 1 minus, or you write probability for A not to get scholarship is equal to 1 minus P of A equal to 1 minus 0.9 equal to 0.1. P of B bar for B not to get scholarship is 1 minus P of B equal to 1 minus 0.8, that is 0.2. Now, let us find out the probability for both A and B do not get the scholarship. Probability that A and B do not get scholarship is equal to P of A bar intersection B bar. Because they are independent events, you can write it as P of A bar into P of B bar. So that is 0.1 into 0.2. That is 0.02. 0.1 into 0.2 is 0.02. Now, what is the probability for at least one of them to get the scholarship? Is 1 minus this. So, probability for at least one to get scholarship is equal to 1 minus P of A bar intersection B bar. That is 1 minus 0.02. That is 0.98. Okay. I am going to explain one more problem. A and B are two events such that P of A union B is equal to 0.65 and P of A intersection B is equal to 0.15. So what is P of A bar plus B of B bar? What's the value of P of A bar plus P of B bar? Now, to get this value, first of all, let us find out P of A union B. What's the formula for P of A union B? That is P of A plus P of B minus P of A intersection B. Now, what are the given things for us? P of A union B is given. P of A intersection B is also given. Let us substitute those two values. What is P of A union B? 0.65 is equal to P of A plus P of B minus P of A intersection B is 0.15. 0.15. So bring that 0.15 to the left side. 0.65 plus 0.15 is equal to P of A plus P of B. The sum of these two is 0.80. Therefore, P of A plus P of B is equal to 0.80. We take it as 1. We have to find out the value of P of A complement plus P of B complement. P of A complement plus P of B complement is equal to P of A bar is nothing but 1 minus P of A plus 1 minus P of B. So this is 2 minus of P of A plus P of B. So this is equal to 2 minus P of A plus P of B is 0.80. So this is 1.20. Now I'm going to explain one more problem. There are three events A, B, C. A, B, C such that P of A is equal to 0.3, P of B is equal to 0.8, P of A, P of C is also given, that is this P of B is 0.4, P of C is 0.8. P of A intersection B is 0.09. P of A intersection C 0.28. P of A intersection B intersection C is equal to 0.08. And P of A union B union C is greater than or equal to 0.75. Show that P of B intersection C belongs to the closed interval 0.21 to 0.46. We have to show that this value P of B intersection C lies between 0.21 and 0.46. Now, actually any probability of any event lies between 0 and 1 only. But here the probability of this event is more than 0.75. That means it is from 0.75 to 1. It lies between 0.75 and 1. So here given 0.75 less than or equal to P of A union B union C less than or equal to 1. It is more than 0.75, but any probability is less than or equal to 1 only. So it should be in between these two values. Now let us expand this one, P of A union B union C. That implies 0.75 less than or equal to expansion of this one, P of A union B union C. P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C, which is less than or equal to 1. This whole thing is the expansion of P of A union B union C. Now let us substitute the known values, given values. That implies 0.75 is less than or equal to, what is P of A? 0.3 plus P of B is 0.4 plus P of C is 0.8 minus P of A intersection B is 0.09 minus P of A intersection C is 0.28. This is not given. P of B intersection C is not given, but P of A intersection B intersection C is given as 0.08. The sum is less than or equal to 1. Now let us add the known numbers. 0.75 is less than or equal to 0.3 plus 0.4, 0.7 plus 0.8, 1.5 plus 0.08, 1.58 positive value. 0.3 plus 0.4 plus 0.8 is 1.5 plus 0.08, that is 1.58 minus 0.09, 0.08, that is 0.37, 0.37 minus P of B intersection C less than or equal to 1. Now subtract 0.37 from that. That is 8 minus 7, 1, 2, 1.21 minus P of B intersection C less than or equal to 1. Now, to avoid this 1.21, first of all, let us multiply both sides by minus 1. Whenever you divide or multiply with minus 1, that less than will become greater than will become less than. So, multiply all the three inequalities by minus 1. So, that implies 0.75 now will become greater than. This is minus 0.75. That is minus 1.21 plus P of B intersection C less than or equal to, greater than or equal to minus 1. Because we multiplied with minus 1, less than will become greater than. To avoid this minus 1.21, add 1.21 for all the three quantities. Add 1.21 to all. And what you will get? 1.21 minus 0.75 greater than or equal to. This will be cancelled. You will get only P of B intersection C only. Greater than or equal to minus 1 plus 1.21, that is 0.2. Or you write minus 1 plus 1.21. 1.21 minus 75, that is 6. 0.46 greater than or equal to P of B intersection C greater than or equal to 0.21. Now if you reverse the order, again you have to change greater than to less than. That implies 0.21 less than or equal to P of B intersection C less than or equal to 0.46. Now that P of B intersection C lies between 0.21 and 0.46. That implies P of B intersection C belongs to 0.21 to 0.46. This. That's all.